Hi, the purpose of this recording is to show you the mystery of L'Hopital rule. What is the usefulness of L'Hopital rule? It is usually used to find the limits of indeterminate form of the type 0 over 0. Then I'll briefly state the L'Hopital rule and then explain the mystery of this rule. Let's look at an example. If I'm going to find the limit of x goes to pi over 2 of 1 minus sine x over cosine x, what is this limit now? We know that 1 minus sine x is continuous at x equals pi over 2, so the value will give you 1 minus sine pi over 2, and this number is 1 minus 1, it is 0. And cosine x is continuous at pi over 2, so cosine pi over 2 will give you 0 as well. And we have a problem now. We are having the case of 0 over 0. And this is an indeterminate form. We do not know what is 0 over 0 since we cannot divide any number by 0. Now let's look at L'Hopital rule. What does it say? It says that if f and g are differentiable on an open interval I containing a point C at which f of c and g of c is equal to 0, then the limit of fx over gx when x approaching c exists and is equal to the limit of f prime x over g prime x when x approaching c, provided that this last limit exists. So for our earlier example, f of x is equal to 1 minus sine x, g of x is cosine x, and c equal to pi over 2. And we have fc and gc equal to 0. So using the L'Hopital rule, I need to find what is f prime of x. F prime of x to differentiate 1 minus sine x. Differentiate 1, you get 0. Differentiate sine x, you get cosine x. So this is negative cosine x. Now g prime of x is differentiate cosine x, will give you minus sine x. Using the L'Hopital rule, this is equal to limit of x goes to pi over 2. Differentiate the numerator, you get minus cosine x. Differentiate the denominator, I get minus sine x. So this is the same as limit of x goes to pi over 2 cosine x over sine x. When x approaching pi over 2, we know cosine x and sine x are continuous at pi over 2. This is equal to cosine pi over 2 over sine pi over 2, provided the denominator is not equal to 0. And we know that sine pi over 2 is 1, cosine pi over 2 is 0. So that will give me 0. Now the question is, why differentiation works? Now if you recall, what is the definition of differentiation? One possible definition of f prime of c is a functional differentiable. Then this is the limit of x approaching c, f of x minus f of c over x minus c. So f prime of c is equal to limit of x goes to c, fx minus fc over x minus c. Now we are given that f of c is equal to 0. So f prime of c is equal to limit of x goes to c, fx minus 0, which is fx now, over x minus c. Now if x is near c, this is what happens when x approaching c, then we will expect f prime of c will be approximately f of x over x minus c, or rearrange them with f prime of c times x minus c equal to approximately f of x. That is, f of x will be approximately f prime of c times x minus c. Now graphically, it means that if you have a curve y equal to fx here, and f of c equals 0, where the curve cut the x-axis, then f prime of c times x minus c is the equation of a tangent line at the point C. So you can see that the curve is very close to the tangent line when x near C. You can do the similar argument for g. G prime of c will be limit of x goes to c, g of x minus g of c over x minus c. If g of c equals 0 and x is near c, then you will get g prime of c approximately gx over x minus c, or gx is equal to g prime c times x minus c approximately. And again, if this is the graphical representation, if y equal to g of x and gc is equal to 0, then y prime c times x minus c is the equation of a tangent line at the point x equal to c. Now let's look at the ratio. F of x over g of x will be approximately f prime c times x minus c over g prime c times x minus c. As we take x approaching c, we can cancel x minus c because x is not equal to c. So we get the limit is f prime c over g prime c, provided g prime c not equal to 0. Now if we assume f prime and g prime are continuous at c, that means limit of x goes to c, f prime x is equal to f prime c, and limit of x goes to c, g prime x is equal to g prime at c. Then you can rewrite the above limit as limit of f prime x over limit of g prime x. And then you apply the combination rule. This is limit of f prime over g prime where x approaching c, provided limit of x goes to c, g prime x is not equal to 0. So finally we have come to a conclusion. Limit of fx over gx when x approaches c, if you have a 0 over 0 case, then this is equal to limit of f prime over g prime when x approaching c, provided the little limit exists. That's the end of the recording.